Hi everyone. In this lesson, we're going to continue to review algebra, and we're going to start using them in some proofs. Nothing too hard, I promise. In Algebra 1, you should have also learned the three properties: reflexive, symmetric, and transitive. If you don't remember them, that's what I'm here for, to help you review them. The reflexive property, although it seems quite simple, you will be surprised how much we use the reflexive property in our course. The reflexive property says that any number is equal to itself. Okay, so we're going to say that A equals A. Any number is equal to itself. It's kind of silly. We already know that, right? We know that 1 equals 1 and 2 equals 2. This property will actually come in handy later, though. The symmetric property says that if you have an equation, you're allowed to flip-flop the left and the right side. So if I say that A equals B, then you already know that B equals A. And we did that in some of the problems in the last video, where we solved for K and we got K equals 10. But when we solved, we actually had 10 equals K. We know that if we have 10 equals K and K equals 10, then it means the same thing. And it's okay to flip-flop those. And the reason that's okay is because of our friend, the symmetric property. The transitive property says that if you have an equation, let's say A equals B, and then you have another equation that says that B equals C, well, then you're allowed to say that A equals C. The transitive property is actually just a very fancy substitution property. Substitution. Okay, it's a very fancy substitution property. That's all it is. We're going to start using our properties in a proof. And we were kind of writing proofs in the last video. You just didn't realize it. The proofs that you're going to see in our class are two-column proofs. And it has two columns. The left column is for the statements, so the steps that we did. And the right column is the reasons or our justification. Now, our proofs will always start with a given. You don't know how to solve a problem unless I give you the problem. So we always just start with the original problem. And I'm going to write that here. 3x plus 12 equals 8x minus 18. How did I know that statement? That statement was given to me. Okay, so we always will start with a given. I like proofs because they always tell you the answer. I already know the answer is x equals 6. I don't even need to really solve. Well, I'm going to solve, but I know the answer already. Okay, so remember, combining like steps is always our first step, like terms, combining like terms. But I don't have any like terms on the left side, and I don't have any like terms on the right side. So we want to get all of our x's to one side and all of our non-x's to the other side. And how you start this may be different than how I do it. But I like to deal with those variables first. Okay, so I'm going to get the 3x's over to the right side. How on earth can I get 3x's to come over to the right side? Well, let's subtract 3x from both sides. Okay, if I subtract 3x from the left side, the 3x's would go away. And if I subtract 3x's from the right side, well, 8x minus 3x is 5x. What did I do? I subtracted 3x from both sides. So I technically did this. You don't want to write that in your proof. It makes your proof look too messy. But that's the step that I did. And so because I subtracted the same thing from both sides, we know that is the subtraction property. This should feel familiar. Now I've got to get rid of this negative 18 because I want the x's to be by themselves. So let's add an 18 to both sides. When I add an 18 to the left side, I get 30. And when I add an 18 to the right side, that negative 18 will go away. Okay, so I technically did this. But again, you don't want to do that little step there. It just makes your proof look super messy. So you won't see that step in the proof, even though that's what we did. I added 18 to both sides, so that's the addition property of equality. Almost there. I need to get rid of that 5. How do I get rid of this 5? Well, we divide both sides by 5. Okay, I divided both sides by 5. Now the very last step. Well, I wanted to prove that x equals 6. I have 6 equals x. So I'm going to flip-flop these and write x equals 6. The property that allows me to flip them around is the symmetric property. Notice there is a word in our proof that is not there. What word is not there? Prove. You will never, ever see the word proof or prove written as a reason. That's not a reason. That's what this is. This is a proof. It's not a reason. So you will never use proof or prove as a reason. There's always a reason. Why did you do that? I like to think of the proof, the reason column is like that annoying little sibling or child that's always asking why. So I'm going to say 3x plus 12 equals 8x minus 18. Why? Well, because that was given. So 12 equals 5x minus 18. Why? Because of the subtraction property. Allowed me to subtract that 3x from both sides. So 30 equals 5x. Why? Because I added 18 to both sides. So 6 equals x. Why? Because I divided both sides by 5. So x equals 6. Why? Because the symmetric property allows me to flip-flop it. So you can think of those reasons as why you did that last step. Okay? Go ahead and try the on your own. Just try it. It's okay if you get it wrong. Just try it. Go ahead and try it now. So hopefully this problem felt very much like the last video. The only difference is there's this box here for you to write your answers in. We start with our original equation. That was given. We need to take away this 5 from both sides. Well, to do that, I need to subtract 5 from both sides. So that's the subtraction property of equality. Now I'm left with 3k equals 12. Divide both sides by 3. I get k equals 4. That was the division property of equality. Okay, example 2. We've got an equation. And we are going to write the proof ourselves. Okay, so you notice there aren't like boxes for each one. We're just going to write the steps ourselves. So we start with the given. We're going to write 4 times 5n plus 7 minus 3n equals 3 times 4n minus 9. Let's call this step 1. If that's confusing, you could call it step A. Okay? Especially with all these parentheses going on, that might be a good idea. Come on, pen. Here we go. So step A. So the reason is given. Now, what do you want to do next? I'm going to use the distributive property. So I'm going to take the 4 and distribute it in, and the 3 and distribute it in. I'm not going to put that in my proof though, because that makes it just look so messy. But that's what we're going to do. We're going to do 4 times 5n. So that gives me 20n. I'm going to do 4 times 7. And that gives me 28. Nothing's happening with that 3n. It's just hanging out here with us for now. Then I'll distribute that 3. 3 times 4 is 12. 3 times 9 is 27. And because it's a minus, we're going to keep that minus. So step B, what did we do? Well, we used the distributive property. All right, the next step, combine like terms. Remember, we always got to combine our like terms. Over here on the left, I have a 20n and a negative 3n. So when I combine those, I get 17n. When you write that as your reason, you could actually write combine like terms. This could also be called simplify. It means the same thing. Now I want to get that 12n over to this side and this 28 over to the right side. Let's start by moving that 12n. I'm going to subtract 12n from both sides. I'm not going to write that little step here just because I don't want my proof to look messy, but I'm just going to go ahead and know that I'm subtracting 12n from both sides. 17n minus 12n is 5n. 12n minus 12n is 0. So I'm left with negative 27. So my justification or my reason is the subtraction property of equality, since it's an equal sign. My next step, I want to get that 28 to the other side. So let's subtract 28 from both sides. Well, 28 minus 28 is 0. And negative 27 minus 28 is negative 55. You are allowed to use a reason as many times as you need to. And I subtracted again, so I'm using the subtraction property of equality again. We're almost there. We're going to divide both sides by 5 to get that n by itself. 5n divided by 5 is 1n. Negative 55 divided by 5 is negative 11. I divided both sides by the same number, so I used the division property of equality. And there it is. We needed to prove that n equaled negative 11, which we just did. So we can stop right there. We did exactly what we needed to do. So we're just using this proof as just an organized way to justify our steps. Go ahead and try the on your own. Yours might look differently when I come back and show you my steps. As long as you got x equals negative 2 at the end and you properly justified each step, I'm sure it probably looks okay. But again, just try it. If it looks differently than mine, that's okay. Go ahead and try that now. Okay, so we already knew that x equaled negative 2. We just needed to fill in the steps on how to get there. So we start with the given equation, and that's given. I distributed that 5. And so when I distributed that 5 times negative 4 minus 2x turned into a negative 20 minus 10x. That's the distributive property. I then chose to subtract 2x from both sides, leaving me with 4 equals negative 20 minus 12x. That was the subtraction property of equality, since I subtracted 2x from both sides. I wanted to get rid of my negative 20, so I added 20 to both sides. That was the addition property of equality. To get rid of my negative 12, I divided both sides by negative 12. That gave me negative 2 equals x. Because I divided both sides by the same number, that was the division property of equality. And on the very last step, I wanted to prove that x equaled negative 2, so I needed to flip-flop my left and right side. The symmetric property allows me to do that. If yours looks a little different than mine and you want to check it, you are welcome to take a picture and send it to me. I'm happy to go over it with you. Okay, that was the end of algebra with proofs. Hopefully this was a good algebra review for you. If you were unfamiliar with these properties, it might be good to put on some flashcards and continue practicing, because they are going to continue to pop up throughout the course, and they're good to know and be able to recognize. I hope you guys have a great day. I'll see you later.